Large language models really excel at working with text and understanding patterns of language. And a lot of times, text is something that's really difficult to work with because we tend to have a human go and look at it to do a really good job of analyzing. Well, or we used to need a human to do that. Now we use large language models, but you know, going through and trying to understand text and manipulate text is one of the real strengths of the large language model. The next pattern is called the semantic filter. So this is basically a filter that can take in text and remove information from it, or only keep information that has certain meaning or has a certain qualities that we specify. And so this can be a really useful pattern for a variety of different cases. Now I'm going to show it in the case of taking text and filtering out or removing certain things that we would like to get rid of from those texts. This might be secret information of some kind. It might be, removing things that aren't public. It could be all kinds of different things, or removing redundant information, whatever you need it for. But this is kind of a useful pattern in taking and manipulating text. So let's look at an example of it. So I'm going to start off with a very simple example of the semantic filter. And I'm going to say, filter this information to remove all dates and rewrite the text as little as possible to fix issues caused by the date removals. And then I've pasted in some information about Vanderbilt University from Wikipedia. And in this information, there's a whole bunch of dates. And so I'm creating a complex filter that's going to basically take in information, it's going to remove all the dates, and it's also going to transform the information a little bit to rewrite it, just in case I'm removing a date and it sort of makes a sentence awkward, or there's obviously something missing. And so I'm going to take in information, I'm going to remove all the dates, and I'm going to slightly rewrite in order to do this. So I've got the Vanderbilt now Wikipedia information, and by using this pattern, which is to clearly say that you're going to serve as a filter. So we're going to say filter this information. So we're clearly indicating by saying filter that we want to preserve but remove. We're not trying to create new. We're trying to take in information and filter out or remove. So the pattern is basically, the semantic filter pattern is, we're going to tell it to filter something, and we're going to give it sort of rules, semantic rules, rules about the meaning and what we're trying to remove, the meaning or the purpose of what we're trying to remove. So then what it does is it goes through and it rewrites all the text, and you notice that it does a pretty good job. It removes all of the explicit dates. Now, one thing I noticed is that I might need to go and rethink my prompt and how to express dates, because it says founded in the 19th century, and that might be too specific for me depending on what my meaning of date is. So I think it took a literal interpretation of it, like if it's a specific date. So if you go back and look, it originally said founded in 1873. So it removed the date 1873 and replaced it by rewriting it with founded in the 19th century. So it's actually kind of removing information, but I asked it to rewrite, so it's transforming it a little bit. But this shows you kind of the power. It's understanding the text, it's understanding what a date is, it's removing it, and in this case, we're also transforming it to rewrite it in some way. Now let's show you a more interesting example, and kind of where semantics and understanding of the meaning of things really gets used. So I'm going to say filter the information below to remove any information that would help someone figure out that the patient has diabetes. First, explain what information you're going to remove and how it might help someone figure out that the patient has diabetes. Then provide the filtered information. So what I've got below is a fictitious medical record that describes a patient, Jane Doe, has a number of symptoms. The patient presents to the clinic with complaints of increased thirst and fatigue for the past 2 weeks. History of present illness right here. Past medical history down here. Medications down here. Allergies, a variety of things. And then I'm going to actually have ChatGPT go into a semantic filter on this information. So now let's take a look at what it's going to remove. So it says, well, the chief complaint of increased thirst and fatigue should be removed because increased thirst, polydipsia, is a common symptom of diabetes. The history of present illness mentions increased thirst and not checked her blood glucose levels, both of which should be removed because they are related to diabetes symptoms and management. The past medical history includes type 2 diabetes mellitus, and I apologize if I'm mispronouncing this, which should be removed because it directly indicates that the patient has diabetes. The medication metformin, 1,000 milligrams twice daily, should be removed because metformin is a medication commonly used to manage diabetes. So this is taking the semantics of, I want things that could give away that this patient has diabetes. I want them filtered out and removed, so I'm giving some semantic rules about what type of information to get rid of. It has to understand to some degree the meaning in the text, or at least know based on its training data that these are things that are commonly discussed around diabetes. So one way or the other, it's figuring that out. And then it goes through and rewrites the medical record. And notice it rewrites the chief complaint be to the patient presents to the clinic with complaints of fatigue for the last 2 weeks. The patient reports that she's been feeling more fatigued. She denies any recent weight loss, blurry vision, or infections. Past medical history is rewritten. The medication is rewritten. And so now we have a filtering of what was here before. And so we notice that, like the history, it removed this. The patient reports that she has been experiencing increased thirst for the past 2 weeks. So we can use these large language models to develop sort of powerful semantic filters using the semantic filter pattern. Now, is it perfect? No. As we've seen, there can be, issues with it. And as we've talked about before, they're not always perfectly repeatable. But as a starting point to help maybe support a human process that then looks over it a second time, or to try to help prevent accidental release, it's just one more check in the system. This is a fairly low-cost check to try to remove extra things. Should it be the only check? No. If we're going to filter things out, particularly for privacy or other reasons where we have information that we don't want to get out, we should always have other checks in place, because this is not going to be a perfect filter. It's going to have some randomness. It's going to not always do exactly what we expect, but as a part of another process, as a component to help, it's a very, very powerful technique that we could potentially employ in parallel or in conjunction with other checks, other types of removals.